Focus on PF56 part 4, that is client impersonation. So in previous section we have seen several techniques to hijack authorization codes. We have also seen that without the knowledge of the client's secret, an attacker can't achieve too much because the secret is needed in order to trade the authorization code for an access token. This continues to hold true only if the authorization server follows OAuth core specification. Ensure that the redirect URI parameter is present if the redirect URI parameter was included in the authorization request as described, and if included, ensure that their values are identical. That means we are trying to match that value from the initial call and to the token call. I'll just show you in the next slide. So let's assume an authorization server does not implement this part of the specification and see what can go wrong. As we have said, all the attacker has in their hands is an authorization code. They don't have any knowledge of the client secret for the client that the authorization code is bound to. So theoretically they can't achieve anything. If the authorization server doesn't implement this check, this still represents a problem, but before we dig into this, let's review how the attacker was able to steal the authorization code in the first place. So all the techniques we have seen used to steal the authorization code were related to some sort of redirect URI manipulation that we discussed already in our previous section. This was achieved because of the OAuth client's poor choice of the registered redirect URI or too loose of an authorization server redirect URI validation algorithm. In both cases, the registered redirect URI did not exactly match the one provided in the OAuth request. Nevertheless, the attacker hijacked the authorization code through a maliciously crafted URI, and we know what are the ways, right? Like we have discussed already in our OAuth client vulnerability sections through the referrer and other methods. So now what an attacker can do is to present this hijacked authorization code to the OAuth callback of the victim's OAuth client. At this point, the client will be proceed and try to trade the authorization code for an access token, presenting valid client credentials to the authorization server. The authorization code is bound to the correct OAuth client. The result is that the attacker is able to successfully consume the hijacked authorization code and steal the protected resource of a target victim. Let's see how we can fix this in our code base. So here we are just trying to, let's say if someone hijacked our authorization code, in that case also how we can stop that to get an access token, because the main agenda is to get an access token. By getting an authorization code you can't do anything, correct? So the main target goal of an attacker is to get an access token, and to get an access token, attacker will trade that authorization code to the authorization server by client impersonation or by other methods what we have seen in the previous sections. So now in this section, what we can do if maybe the code is like somehow maybe hijacked, right? So let's see how we can fix this in our code base. So under authorization token endpoint, you just need to put this code, like this is a simple understanding for that. So if code.request.redirect URI is not equal to request.body.redirect URI, then you need to put the status 400, that is error, invalid grant. So what it exactly is doing, so code request redirect URI is not equal to request body redirect URI. That means that in the initial call, when there is a authorization code call has been done to the authorization server, at that time there is a redirect URI parameter has been sent to the authorization server, correct? And now it's trying to validate with the same address in the token call that whether that address is present in the body or not, right? So if the code.request.redirect URI not equal to, if it is equal, it's fine. In that case, we can just go for the next step, next action. But if the code request redirect URI is not equals to the request body redirect URI, whatever the request coming, it's not going to match with the body redirect URI that is came in the you can say the first call, right? The authorization call. So in that case, it will just go for an error and give the invalid grant. So when the OAuth client presents the hijacked authorization code to the authorization server will now ensure that the redirect URI presented in the initial authorization request will match the one present in the token request. That's what I'm saying, right? So basically, what we see that there is a first authorization call where you're just passing the redirect URI and other parameters to the authorization endpoint, where the ping federate or any other product will go for and handle the authentication, like go for the consent part and then generate the authorization code and send back to the client callback address. Now client will again go for the token call by passing again the same redirect URI parameter and other the client credential details and sending this to authorization server token endpoint to get an access token. Now when this the second call will done, in this case the authorization server now will try to do this validation, will ensure that the redirect URI presented in the initial authorization request will match the one presented in the token request. So now in the token request you are passing something and in the authorization request you passed. So those two redirect URI is same or not. If it is same, it's fine. If not, it will simply deny. It will not go for the token generation. Since the client is not expecting to send anyone to the attacker side, these values will never match and attack fails. Correct? Having the simple check in place is extremely important and can negate many common attacks on the authorization code client. This is by just I'm just trying to just show you by just putting the simple code, you can just avoid this part. Like someone hijacked my authorization code also. In that case, if the attacker can just try to go for a token call by just passing a redirect URI, malicious just starting some redirect URI with some adding some crafted like malicious address and then sending to the like let's say to the ping federate authorization server token endpoint. Here ping fed will simply check the request came in the authorization request. Is it matching? Is that redirect URI matching in the token request or not? If it is matching, then it's fine. If not, I'll deny. And in the case of attacker, it will definitely not match because the attacker's site redirect URI is definitely different than the client, than the legitimate client what in the initial they requested. It will not match, and then hence that authorization server will break this. By just putting the simple check, you can just avoid this. Okay, so this section is just talking about that part only, that if the somehow the authorization code is hijacked, how you can stop the token generation from the authorization server end by just putting this logic, checking the redirect URI parameter from the request in the initial and to the token request. Okay, I hope you understand this. If you have any confusion, yeah, please put in the comment section so we can discuss again. And there's one more section left, I think, for this authorization server vulnerabilities. So let's discuss and then, yeah, we'll just talk about the token vulnerabilities also. Yeah, thank you.